Hello everyone. Haven't gotten started yet, but it might be a bit interesting this time. Right now, I'm just talking a bit with Ginger Bill actually. Chatting. So, all right. Let's see. Oh yeah, time already past 5 minutes. So, all right. The thing is, I will start now. Yeah. Let me see if I can turn on the webcam in case you want to see me as well. In case I make some weird gestures or something. All right. The thing is, when you have something like this, when you start generating code, let's look at the code gen. I'm just going to make sure that you see my screen right now. Yeah. Okay. So if you have something like this, you start with. Let me see here. You have the LVM cogen, the first thing here. So you start doing cogen. You set up whatever you need to do for the LVM builder, the module, and so on. And you might, do like this and emit whatever functions you need and methods and so on, and types and global variables. Sorry about that. Anyway, and then you start generating the function bodies. It's nothing weird. You might do a bunch of stuff, which I do right now. Like, look at this. We get the API stuff here, right? And then you start emitting statements. You have a list of statements and you emit them one at a time. And so I go like, here I want to emit something, and I just going to do that, and then I'm done. And then we have something that is more interesting, which is an expression, and then you go like, here's something for the fillables. But you go into this basic thing, which is like emit expression, and then there are some expressions that you can't have, like raw, so those are here. And then we just jump to whatever these are, and they are usually static, might be static inlined, but we do something, and we have like the normal, we usually you have like a lot of binary expressions, because that's like the meat of everything. You add something together, right? And then you have something which is interesting. If you think of an assignment, which is this, right? You need usually you need a value. So you have a variable A and maybe a variable B, and you want to add them. Then you want the values. So you want to actually, in a programming language, you actually have an implicit sort of take the value of A, right? And then when you assign something, there's an implicit like put this into A, right? It's not. So then you have like the address of A that you want to have. So those are different. And especially when you have like a pointer can be dereferenced, right? So then you can put something into that, but it can also be dereferenced and be a value. So like if you have something like a pointer to a pointer, so if you have something, let's like write code here. So if you have something like this, x, and if you do this, then this is still like you can do int y is like so what to say here? So okay, it's uninitialized. So it's no, whatever. So okay, so this is okay, right? But this could also be okay, right? So here it is a value implicitly, and here it is an address. So in the case of a sign, we take our expression, but we don't emit it as an expression, normal expression. We emit it as an address, right? I get away with doing this. So a lot of these expressions can't be an address, and we already fixed that during semantic checking. So it could only be like an identifier. It could be a unary that is a deref. It could be like there are some other cases that we get, and it could be, maybe call, I don't know. Anyway, there are some cases where you just want the address. These are actually not addresses. These are not like when you assign something to it, but sometimes they are addresses because you don't want them as values. But this is not great. That means you have to, sometimes I will do like, you can get, if you think of something like you want to take something as an address, like you want to know, like maybe it's a value and then you want it as an address, and then you want it back as a value again, or an address again. So you kind of get some unnecessary conversions to values. That's what you get. So like if I take, for example, if I do this, right? Write some code here. Okay. So if you think of like if I have x, right, and I have y, and this is some value here, let's say 2, and I say 3 here. When I do this, x equals y, let's say this is some big struct instead. So in that case, I would just want to do like a mem copy. So then I just want the address of x and I want the address of y, and then I want to do a mem copy between them. So I want to do like a mem copy from like the address to the address of y from the address of x, size of x, right? So this is what I want to do. I don't want to like take the value of y and then store it in x, because if it's a struct, that is a bit unnecessary. So sometimes we don't want that, because especially since LLVM will treat a struct as an address anyway. So if you load it, that's like bad. You just want to take like a pointer into something somewhere deep inside of LVM and then load that particular thing. You don't want to like load it as a value and then pull things down to that. LLVM doesn't like that, and probably if you would implement this, you wouldn't, if you would write your backend yourself, you wouldn't want to do that either. So how do we do this if I just return the LLVMValueRef? And then there's another case, like when you have a Boolean, because LLVM will treat a Boolean as an 1-bit thing. But when you store it, you want to store it as an 8-bit value, like a byte. And then when you pull it out and want to treat it as a bit, single bit, you want to sort of truncate that, whatever value you had. So if you pull it back and forth, then you want to, you know, treat it as a go between value and bit representation. And like if you have it stored in a struct, it will be like an integer, a byte, and then you want to pull it out, truncate it, you know, do a comparison, then extend it again and put something back, right? And doing that is possible. Then you have to like take care of every single case. But it's sort of, it adds a lot of complexity, like taking care of all these cases, because they only fail when you do a compilation. So here it broke. This is one of my tests, I think. Maybe this broke on something else, by the way. But anyway, so we have, this is a problem, right? And a more ambitious way would be to sort of have a value wrapper around this. But if you want to, since the LLVMValueRef is already pointer size, so it's 8 bits. So if I put something more into that, like return something, a bigger struct, then that will mean I need to copy things back and forth, and maybe I don't want that. Maybe I just want to pass a ref all the time. Maybe that's better, and we don't need to, you know, think about allocating the struct back and forth. Even though it will be pretty efficient on C because of how it works. So what I did was I created something which I just called something that is not here right now. Let's see. Yeah, here it is. So BE value, backend value. I want to something fairly short, otherwise I'll just take a long time to type. So and now we have like, okay, it could be a value, or it could be an address, or it could be a boolean. And I also keep the alignment, because when I started reading about LLVM, I like looked like I was reading the optimization code, and it said like, oh, and they do something alignment. I was like, okay, I shouldn't have alignment, but it turns out that it's the opposite thing. Like you need the alignment, because otherwise you can't do the correct optimizations. So I want to pass the alignment around, and now we have a lot of things that we want to pass. So this is basically what we want to pass. We want to take like the original type, the one I know about, like the front end knows about, and the value, whatever that was, and like the kind, because sometimes it's a boolean, right? And there's like bit boolean, okay. And I don't have that representation, so I can't represent that and do conversions. That would be like pretty messy. So what I will do is I want to like go over, start using BE values. Now the problem is that nothing in my code uses BE values right now. Like everything is like returning LLVMValueRef, and we have tons of code here, and everything is just doing that. So I need to like ease in the code, doing refactoring in a responsible way. Now things are not working right now. Like ideally this would be working. It is not, because I think like because of the failable. So I have like a choice here. Like, do I fix the failable thing first, and then I have test suite and it will work. But also this thing might help me, you know, make the final stuff that makes it work. So it's a bit. I will look at what's needed to get the failables working. So I guess that is the main thing here. So let me see. It is not here, not here, not here. It is probably somewhere. Okay, I can get here. So return switch. That one is not working. So I'll check why that one isn't working. And I'll just take this code, move it into my debug thing, Cody, here, and I will try to compile that, and I will fix whatever problem there is. So here is the return switch thing. Oh, that worked. Okay, maybe some other error, sorry. So the tester said, okay, a search variance didn't work. No, that was the old one. Okay, I need to run this again. So, okay, here we have a bunch of them. Okay, so we have rethrow doesn't work. This one doesn't work. And that's a fairly short piece of code. All right, so we end up here. Okay, so now what happens here? So we're going to meet the function body, and what happens next? So in this case, we have a function that has a failable. And now we do have a return out, but we need to start with the failable. So if we have a failable, right, and then we have to look at like failable and signature create API info kind equals API direct. In that case, we have a failable out, which is this one. Right? So otherwise, the this one is no. Right? And then maybe we have this one. We don't know. In that case, we have the return out. And then we have to emit the parameters. And I guess we need to emit the parameter. Let's see here. So, okay, so in this case, okay, we do the debug scope thing. That one should probably happen before. Okay, so in case it's like this, right? It's a failable. Oh, then we need to emit a parameter as well. No, that will always be like those are not handled like that. What happens if this one is, yeah, so it can only be indirect. Okay, that should work. For that one, that part. No, failable. API info. I might not, because this is going to be a bit boring for you to watch. So I will do the refactoring next. I'm just going to fix this part. So implicit return. Right. And we'll handle that later on. So that's why it's breaking. Because something here. Like the return out is 0. It's a failable. So then we have the info, which is all right. So here we should go like, okay, what is the like the info now is the signature failable info. So that should be like more correct there, I think. Yeah, but we have some things that are not matching the operand type. Let's see here. So we have something that is returning just available. And then we do a ret. That looks okay. But what happens? So we have a comparison. Yeah. So this is not working because there's a comparison thing with to check that something is if it fails. So I think that will be emitting stuff to the available. I think. All right, I won't do this now. Okay, sorry. Right, so let's get back to the refactoring. And I just need some simple code here, I think, to play around with and see that it works. I had something here. And let's just see that works. Right, this was something I used for the API checks. Right, so this is interesting how much is broken here. Okay, but what we want to do now is that we, instead of returning a the value, we need to go to the LLVM codegen expert. So instead of returning a value, we will return an expression. Okay, so here we have gen context emit unary expression. Maybe that's a good place to start, right? So I am going to introduce this one as a in parameter, and then we need to remove this one. Okay, so maybe I should, yeah. So that's the only usage. So what we want to do here is take this one, and you want to have like there's a b value to value. Okay, so that one will take whatever value I have. Maybe I should just have a b value on top here. B value. Then I don't need to generate that. So here we don't need that, and I can just return this. That is nicer. Okay. And I also noted that I could do some other stuff that would be nice. Okay, so we want to do this b value to value later on. Then we just need to do a b value to value of the context and the value that we had, but the reference to that. Okay. So we want to do this. Take this ordinary function, and we want to do this, and then we can return the b values value. So now it acts just like before, but we'll do some stuff. So type reduce from expression, whatever that is. Yeah, it's the type lowering. Okay. So in this case, we have the t is an addr that is taking the address of something. So that way we actually get a right. We wanted to. This is actually from like when you do a you have an expression like a temporary, and then you actually have that as just as a value. So you need to allocate memory for it. Then you want to build a store. You want to, store that, and then you return the address. Funny, this would always be an address. Yeah, so it's a value, of course. It's still a value. We are not taking the even though it's a pointer, it's a value. So we just do a normal be from value. So we take like the value we take the value that we just created, temp, and we do the type. Okay, and we are done here. So that's done. And then we do a not. And like here we actually get something interesting because we can apply whatever we did. So here we have something. I should have like a b from bit from comp comparison from bitbool from boolean. So this is an LLVM value. On the type will always be value will be type bool. Bool, I guess. Okay, and the alignment will always be like the you can just going to assume that this is the type bool, right? Boolean even. All right, so we don't need that one. We could possibly check for it, but it's now a b boolean. We need to add this one to our header. Maybe just I'm going to store this b value to the dictionary, or I'll get the corrections every time. So we put the b value from boolean right here. We have the value itself. Okay, so now we've loaded the boolean value into the b value and we're done. Otherwise, take the hang on, we can do some other stuff here. We can whatever. Let's just duplicate this code. It's not a super big thing. I think that would be easier to read. Okay, and then we have the bit negation. So that is always needs to be a value. So let's say b value from value, and then we have like this part, this bit not, and we have the type, which is, we already know the type because it's up here somewhere. No, we need the value first. So value, blah, 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 and the type. Let's see here. So I forgot this part. That's why everything looked so incredibly weird. Right, and we want to build a not, bitneg not. Okay. And here we want to build this one. So we keep on doing this, and the reason why we want to do this is not going to be obvious until everything is done. So then we are not going to pass around the expressions anymore. We're going to pass around the values. Suddenly, it makes sense. So again, we're going to do this. Maybe want to, maybe just want to put that in a value and then break. It's going to be like so many cases where we get, take something and put it in a value, and then we're pretty much. I think this is getting a bit messy. So let's do it like this. So LLVMValueRef as a value. LLVM value. Okay. So now we can do like we could do the reachable. Now we can't do the reachable there because we want to break. Maybe we can do like this. Done. And here we have like this. Okay. Right, so now we can do this. We just say that the value LLVM value is this store that actually it should use like this in context store. It's store context store something. No, LVM. I started changing this the way I do that, and it's slightly confusing. So we have the LLVM value and the val of whatever that expression was, and the alignment, and then we're just going to do like this, and it's going to, I think, store it by self-aligned, sorry. Store self, expand self-aligned. Expand self-aligned. This is not quite correct. Store self-aligned. Okay, so now we need a type. So now we stored it, and then we can just say that the value is, we already have that. Okay, so we break. And now we realize that we don't need that variable either. Or I realize that. That we don't need this. Okay, in case it's a float, let's do blah, blah, blah. And then we do this one, and we say that the LLVM value is this. Right? And then we do a break. So then we again have, we're not quite done with this. Like this, we are just doing the this unary the stat expression, and you see like there's already a lot of stuff I need to do to make this work. And this is like doing this by hand. That's why you don't really want to do like too much of this. Like you have to get a feeling, is this worth it? And in this case, here we have like simple, it's like just the LLVM value is this. But actually, something you should know is that later on, we will do stuff here. So there is a reason for this. Because if you do something, you have a value, and it's a, like if you get instead, you have like this b value that you get back from the expression. Like you get the b value. Now the b value might be a Boolean, a single bit Boolean. Then you want to like, okay, let's keep that a Boolean. But if it's something else, like this one would keep the Boolean, okay? Like a Boolean will just pass through this. But if you have a negation, then, okay, this is like, that shouldn't happen. But if you have like maybe, well, anything else, then you want to, create a value, maybe. So let's see here. Here's the value, LLVM value is that. Then you break. Then we have different stuff, because we might want to insert a overflow check. So just let's say the result here. So the LLVM value is this. Then we break. Okay. And otherwise, like the value will be this. Is this, right? Then we'll break. Now we should be breaking on everything. Okay. And here, if it's an address, then it's obviously, again, the LLVM value is the address. Then we'll break. And then here, it's interesting. Like now, we don't do that. So here's the dref is the only place where this gets different. So here, instead of doing this, we will like make a b value from address. So now this we have the value, and then we have like this expression, but this expression is something, just a value now, so it needs this address, so it needs a load, and that is the important thing about this. So now we're just going to return from here, right? And here we have some pre-ink deck, and we want to, okay, so this is just going to be like, again, the LLVM value is going to be this one. Return, and then we have like the LLVM value is going to be this one, because you always, like if you have a you can't assign to a whatever, you have an ink deck. So and then, okay, we're doing break, but we shouldn't do break. We should do like go to done, go to done, but we're going to call it something else. Go to return value. Okay. Can't find it. Did I need something? What? I am so confused. Okay, so we are going to do a go to return value, go to, and we have those just as well, go to return value and go to return value, go to return value and go to return value, and go to return value and go, yes, so these are fine. Maybe I'll do it on, but for now it's going to be. Well, later they will return a want me to do the wrapping. So that's where we will do it different. But now we're done with this one, and it's going to return, a b value, and it's like, and hang on, is this used anywhere else? No, then it can be as a static. Okay, so we look at the use here, and we get the value, so we do this. So now it should work. But just to test it, we will do a lot of unary stuff, right? So let's just take, maybe you can run this. So I don't know if this works. Just get it. Okay, so that makes sense. That's the correct one. So now let's do like int d is c, right? And then we can take like int d is 3, right? And then we do a printf of d and d, whatever that is, and then we take like take d and then c and maybe a negation of a b, and then we can take negative a. I would say like a is 23 and b is 11. Right. And then I had one more. Okay, so d, I got something else. Let's run this. Boom. And then I have run this, and I get like, okay, 3 minus 12. Yeah, that would be the negation, right? And well, is that right? Okay. Yeah, it should be. Like the negation of 0 is supposed to be. Let's see, that works. Oh, you can't negate a comp int, so let's cast this one to int. I think that's, I tried many ways to do casting. So right? You get the -1. And you can do this one, right? So you get like the max int or something, max something. Okay, let's see. That should be right, because that's all negative, and that gives 0. Yeah. All right. So this one becomes -1. That was something we saw, right? Yeah. Okay. Next up, we are going to like, if you think about this away, like this is going to give us the value, but we also have, like, I have emit unary address, unary for the address. So we have like gain takes emit address. Okay. So in this case, we just want to emit the address. And right now we have like a special thing. Okay, so it's a unary. Let's do the address, right? So if we could, you know, let me see here. So it's just going to do this, right? So it's just going to do an expression, like sort of, on the unary. But we don't need to do that. We can do like this. Now we have a b value, like the value, right? And then we do a gen context, and then like have the unary context, emit unary, maybe unary is further down, unary expression. Let's say, okay, it's down there. So we need to pull it up so we can see it. Okay. Right. So emit the address here. So now we can do gen context emit unary expression. Okay. So now we can take this value we have and take the expression, the whole expression. So now first just let me prove that we are going into this code right now when we do this. Yeah, so it hits it once, yeah, because we only have this code here once, right? So we could do it again, just for fun. Right? See that it actually goes there twice, once, twice. Okay. Now let's say we do this, right? And now we can assert, instead of asserting that it is a deref, we want to assert that it is an address. So we can check this here, like what is the kind is be address, right? Otherwise things are bad. And if it is, then we just return now the value, because that is going to be an address. And we can remove this one. Okay. Right. Let's see if that worked. So we got the, yeah, that worked. So okay, we are doing that, and just let me add, instead of this one here, let me just add the deref of d, just making sure that it knows to transform that into something right here. Oh yeah, oops, wait a minute. So now it isn't, right? So this is broken. Man, it is broken. Okay, so so we get to the taking the deref, right? So it's getting the deref, like twice, 1, 2, and then the third time. So now in this case we need to, like, we step out, so it's going to take that and go to a value. So it should not be, should be an address, right? And now we want to like take this okay, once, twice, and the third time. Okay, boom, and we go up, we go into this one. Is the value B address? Value type. What? Value kind, maybe. All right, that explains things. We don't need that one. We should just work. So let me see it. Okay, so now it works. Okay, but that explains like why you want to do this. So there are going to be more of them, like going forward. And now it's like basically just hard work. But oh, there's one more thing here that I didn't do, and maybe you didn't like or didn't really show or something. What you should do when you take the address of something here. Let me see here. So here I take the address, and because it's not doing it the right way, here we should actually, you know, let them know that we're taking the address of something that has a particular alignment. So not just this, it's like we take the address, right? So the address is going to have an alignment. So what happens here is actually we are going to do different things here as well. So like there's pick up the alignment. So that is something that's necessary. And here we have like take the b value from address, but we are doing that, you know, here we should be taking the also the alignment that we have, and we're not doing that right now. So we will add that as we go along, and when everything is done, we're going to have like a lot of there is going to be some refactorings that we can do, but we only do that when everything is done. So that is a bit painful, but we're just going to like let's take another one. And now we know that, okay, we do a load, we use the value. Okay, so we do a load on whatever expression we had. We're going to make the expression, and that's not something we need to do later on, but okay. So we want to emit this one, and this is the current value, and then we are going to store that, and then we're going to put that. So we're going to take like b value from value, and we have the value, we have the current value, and we already have the type of this, so we're going to set that to the type, and then we're done. And similarly here, we want to do this at the end. We want to have a value, b value, and then we want to have the current value, and that is also what we're going to use here, right? And then we're going to have like a void return on that one. So now some code is not going to be happening with me. Let's see what code is breaking. So here. So it says like a y pre-inktick, right? But now we can say, okay, let's, we are just going to use, you know, the value here. So please use that one instead. Right? And then we just return here because we're done. No need to wrap that. We are already done. And let's see if that works. Okay, there is another place where this happens. So emit post ink deck. So we need to have this whole thing as well. So this one takes a v value. And post ink deck takes a v value, which is this value. And now it's not returning anything anymore. And then I'm just going to check that this one is actually, now it can be static as well. And let's see where that one is used. So now we have something, so we need to do one of these b to values. So because we have a value like that. No, the address over. Sorry. And they'll do a conversion so it becomes a value, but it will be anyway, but still. There is a post-unary BE2 value. So let's make it into value, then we return value. Okay. Then we have a scoped expression. This is interesting. Okay, so we are going to, oh yeah, this is in case we have differs. So again, we're going to, like we will get a void. We have the BE value, and then we just going to BE value from value, LVM value. We can just put that up here. Already, nothing lost. Set the type as well. And have value. Okay. Now we're done with that one. So we can take the scoped expression, say that it takes a value. Do this, and then we'll copy paste. Right, you see the basic, the geist of it. So we now just go through everything here, really, and try to, meet everything. Here's a call. It's a call. It's a b value. And so it takes a value, the address of a value. Doing the call is like the one of the bigger things. So let me just see that everything works here. So we have a lot of things here. So sometimes we take the address and so on. So here we get a value, and maybe we have like this b value instead, because we're using value everywhere. Maybe it's bad to have value. And we have some return somewhere, like the call, right? So be value from value, b value, comma, call, comma, and then like the function, expression type. Now let's see that if that was the only exit. So in that case, we are done. Right. Now function calls should be fine as well. And here we have something interesting. Like here we are emitting an address, right? And we do a load on whatever address we are handling. So here actually this one would this here is a load, but we can emit this one as a B value from address. So because this will become an address, so okay, we can do that later maybe. Here we have something else, like this is similar. This will also be, you know, the wrong thing. And this is, here is emitting this as an R value, right? Let's see, here we have some interesting stuff here. So in this case, when we do a load, that's when we actually do this check. I don't know, because here's, okay, here's a plain load. What happens if we just use an identifier? Okay, so in the case of taking an address of an identifier, I don't know. Here's the analyze of the expression value, right? Well, I'll think about that for a while. Emit type ID, we can do that one as well. Let's rename these. BE value. So we add a BE value, BE value. I think this is static as well. And a void. Now if, let's see here, if, oh wait, this one is declared there. So okay. It's used in different places then. No, it's just used here. Why is it here? Okay, there's no need for that. Let's make it static. That's fine. Okay. So in the case that it is a built-in, then we want to, you know, emit a const int, which will be a value. So we have like be a value, I guess like this. So in case of this, let's say the value is this, else the value is this. We can insert, and then we value and take the B value, sorry, the value, and then the expression type. Okay, and then we need to look at that one. Of course, here we have one of these. So we have a B value. Value. Okay. Right. I think we can probably at this point in time emit B value like this. Put this stuff down here. Emit B value. Right. So then we can we will remove everything like later on. So emit B value will be just return. emit slice. Okay, so then we have again a b value. Let's see if we have a load here. Oh, hang on here. So we have like a slice. So we're going to build this result. We're going to build a so b value from value. So this is it's going to create a slice on the stack. So this is just a value here. And that's fine. And we should start with the b value. And then we have the type, which is expression type. Right. And then we're done. So we can only take the slice of an array and a subarray. And think about that for a while. We have also a variable array where you can actually get parts of that one, I guess, a slice. So that's something that should be done. I don't even know what this is. I forgot. Okay, so this is var array, which is not support yet. Okay. So then we emit the slice. Now we can do that one as, you know, the variable value, like this, and then just go to emit b value. Okay, we have this one. So now we are going to do this. And a length is always a value, so I'm not sure what this is, a helper function, but it is. So I need to, I should just inline this. I don't know why that is a mid-len. Okay, so inner, right? And just emit load here. So this is not needed. So here we can actually return this as LVM. So here we're saving some work then. And instead we're just going to take this len adder, and the type is type useSize, b value. But in this case, on the other hand, now here it is like a b value from value. So now we are returning different things. Depending on type, and this is good. Again, we're saving some stuff here. Is the inner? What's the value here? So it's the pointer to the subarray. We want to emit the length. We can do that for actually like case, type, var array as well. And that's it to do, and it's for the string. Okay, let's see where it was used here. Now instead we have this value. So we do a go to return b value. have the slices sign. Okay, so this is going to be like a, after everything is done, we're meeting in the block, and we have the value, and what is the value? So like this up here, right? That means we will, and in the end we will say like, okay, BE value from value is a value expression type, and sorry, BE value, and then we're done. But later on we can do something different for that. Okay, let's see here. So we have the BE. Like that, all right? And now this one will use it as well. So now we have just a tiny subset, it seems, but that's not completely true. We have like, okay, the const expr. Those are likely to be pretty simple to do. Like everything here is going to be, well, this is odd, since this one should be, yeah, type string should be a, also similar here. Do a break or return. That works as well. Do I have any questions for now? No? Okay, so I am doing the B value from value, and I'm going to actually leave this for now because this actually takes a while, and this now is just like simple work from here on, just doing this over and over again. And the fun stuff will happen later. Oh, now we have something fun. Oh, we actually have something interesting here. We have this one. So in this case, we are not returning a value either. We're returning a boolean. So we need to have the, oh no, it's no, not, ooh, this is wrong. Look here. So it's an int, right? But it's a bool. So I think here the correct thing is like a LVM const. Oh, maybe it's okay. Okay, so maybe it will do it the right way. I get an int using the type, and the type is going to be a boolean. So no, the type here is going to be wrong. So we need a LVM int const int, and we're just going to use this stored bool type, which is the one. So it's going to be like, okay, is this expression const expr b const expr, please, 1 and 0. Okay, so that's not really needed, but anyway. and we're not going to use the sign extension. We don't need that either. We don't need the type. Okay, so now we have a one of this b from Boolean. That's going to be interesting. Let's take this one because for now this is going to be correct. And take the global name and so the type, whatever the type is, type. Okay, because right now it's like just going to lower to something else. Okay, now we are doing this for all the constants. So let's see. We only have those in one place, then we need to make it static. Now we take the value and then we do the lowering, go to return b a value. Good. So now this will actually make, like if you have b equals, like if you have true here, so I can do that. Let's look at the code for that. So b, we have a true somewhere, we have a temporary. I think. Okay, well maybe we need something else. Let's see, c bool x bool level up equals true. And that doesn't even work, and that's correct. By the way, it's going to make a store 1 into true and try to store that into this one. Because I don't think the lowering is doing the right thing right now. So what happens to the lowering? To value. If the type build trunk. Okay, so if the type is a value, okay, to take it to be a value, then it goes down there. But if you want to make it for storing, then it needs to be something else, actually. So I guess I did this the wrong way around, so it won't actually work now. But that doesn't matter much. So if you take a boolean and make it into a value, it should retain its booleanness to value. So then it shouldn't do anything. So it will happen later on if you want to store it or something. So like we should have like a void b value to store. In this case, you want to have like a b value, and then you want to like have, so in this case, like if value type kind equals type bool, then you're going to like the value is going to be value LVM zero extend build zero extend of a builder, and then take the current value and then turn that into a byte, right, like this, and then change it into a b value, like this. So, but it won't do anything to an address because you need to have that. Okay, so that will happen later on. Okay, because we're almost done. We could actually do this, right? We could do this now. We're almost done. And just for the case that we need to do, so here we have the value. We don't need that anymore. We're going to do that. We're going to do this. We're going to do this. And this is a to do right now because we can do like, but we can do this. This. No, we can just fix this one as well. I don't know. Man, I don't know. Maybe we should wait with that. We could do that, but I won't do it. So, right. Maybe it's a good place to stop. So but some things don't. And I will just continue doing this. And the fun thing goes when, like, if you go into the binary, because then we have like a bunch of them. So here we have like the sign, and it's going to, if it's a binary op after a sign, we have all these, right? And then it's still going to return a value. So in this case, it's pretty simple. But if it's an assign, let's see, no, it's going to return a value as well. But it could return an address. It could return an address here, I think. We're going to see. Here we have this assign expression. It's going to do a store and and have the value that was just assigned, and it's going to put that in there. But as well, you return the reference to that. Because this assign can actually take not a value, but you can do more things as you go along. It's like as we slowly migrate to the B value, it's going to be nicer and nicer and nicer. And for example, like this here. So now it's going to take an expression, right? But it will actually emit a should emit a Boolean. But if it's not a Boolean, if it's a value for some reason, then it will do a truncate. And it probably will do a Boolean. I don't see why it shouldn't do one. We could check that, but right now we can't because it's incorrect. So this is all going to be super exciting if we can simplify more code later on, because I think the whole adder, this one, like to address, that one will like go away. We will be able to remove that entirely. So I am excited about that, because it will simplify things. So it's like, this is like some closing words. Like, this is super important that you like now this was just an experiment. So I've done some coding here, and it feels like the code is getting simpler, not more difficult. I could be feeling the opposite way. So if I had felt like, okay, this is getting harder, I would probably just revert everything, start all over, and just keep on doing whatever I was doing. Maybe I need to think about it more or something. But this time I was pretty sure that, okay, it was starting to feel good, as I was programming here, and I will probably keep this. And there are more things to add to this. It's not quite done yet, but it has potential. And since I have this wrapper, I can just, if I think of more things to add, I can probably add that. For example, there is this range that you have for assigning certain expressions. Maybe I can, put that in there as well. It's not that. Sorry about that again. It's not that this the current way of doing things is like broken. I can patch that, but it will probably not be as nice to work with eventually. So I will do this refactoring, And as you see, it's not really, it's mostly affecting, I think this will be mostly affecting the expressions. So the statements and everything like that. There are some things in the statements, of course, they use expressions to figure out things like if expressions, but I think that we will not have to do too much when we get to the statements. And all of this is to get like everything working in a nice way before I check it in, like the next revision of the source code. I will not check this code in. You can follow what I'm doing mostly if you look at the code. I don't know. I'm not. Okay, maybe I can just push this. By the way, I realize that it's checkpoint v value changes. So if you want to follow along, you can do that. I check the source code. It's in the in dev. Dev is probably not quite correct right now. Like aside from these errors, there are more things that are broken. So dev is definitely not to use. It's like in just for you to have a look at what we're doing when you watch. Okay, good night everyone. It's almost 10:30, so right.